I had problem number 40 from chapter 6. My problem asks me to indicate which of the following are resonance structures of beryllium chloride or BeCl2. For the others, I am to explain why they are not resonance structures of BeCl2. The first step I took in determining whether or not the structures were resonance structures of beryllium chloride was to determine the total number of valence electrons for BeCl2. Chlorine is in group 7, therefore it has 7 valence electrons. However, there are 2 chlorines in beryllium chloride. Thus, I must multiply 7 by 2 in order to get the total number of valence electrons for Cl2. Beryllium is in group 2, therefore it has 2 valence electrons. The total number of valence electrons for beryllium chloride is 16 valence electrons. When determining whether or not the structures are resonance structures of beryllium chloride, you can look at the total number of valence electrons for each structure. Structures A, B, and D have 16 total valence electrons. Each bond is 2 electrons. For example, if you count the number of electrons in structure A, you will get a total of 16. 2, 4, 6, 8, 10, 12, 14, 16. I can do the same for structures B and D. Another factor in determining whether or not the structures are resonance structures is whether or not each atom has enough electrons to form a complete octet. Chlorine wants 8 electrons to form a complete octet. If you count the number of electrons in each chlorine atom in each of the 3 structures, you will get 8 electrons. 2, 4, 6, 8, 2, 4, 6, 8, 2, 4, 6, 8, 2, 4, 6, 8, 2, 4, 6, 8, and for the last one, 2, 4, 6, 8. In each of the 3 structures, chlorine has enough electrons to form a complete octet. The same goes for beryllium. Although beryllium is an exception, it too can have 8 electrons to form a complete octet. Each bond is 2 electrons. 2, 4, 6, 8, 2, 4, 6, 8, 2, 4, 6, 8. Each of the 3 structures has enough electrons to form a complete octet for both chlorine and beryllium. Therefore, structures A, B, and D are resonance structures for beryllium chloride. However, 2 of the structures are not resonance structures. Structures C and E are not resonance structures for beryllium chloride. When looking at the resonance structures for BeCl2, the central atom is beryllium in all 3 of the structures. However, in structures C and E, the central atom is chlorine. Chlorine cannot be the central atom for beryllium chloride because chlorine is more electronegative. Because it has more electronegativity, it cannot be a resonance structure for beryllium chloride. The central atom has the least electronegativity. Therefore, beryllium would be the central atom in beryllium chloride. Structures C and E are not resonance structures for BeCl2. Chlorine cannot be the central atom.